team, William Disterdick, and I'll be going over our frequency response data. This is how we solve for our variables. We had a varying input signal. The height of that amplitude was delta m, and the distance between the peaks was our t, and our little t dead time was the delta, or the peak of our output minus the peak of our input signal. This is one representation of our frequency at 0.05. Here's our input is in blue, and our output is in red, where our t is calculated, and then our delta m and our delta c for the output. These were done, we took 3 measurements of each, and we averaged them together to make sure that we weren't just taking one spot in the graph and saying that was our answer. You can also make a list, I don't even know how to say it, Lissajous figure, which is just our output versus our input. And here is how you can calculate also the delta m over the delta c. This is zoomed in a little bit on the same frequency of 0.05, so we could better see where our phase angle was, which you can see is very minimal. That we calculated with our little t out of our big T times 360, which we got from the previous graph. And our amplitude ratio is delta C over delta M. And this is some more variables for our frequency of 1. As you can see, we start, as the frequency starts going up, the output and input will start delaying more. They won't exactly be in phase with each other like they are at slower frequencies. Again, there's the output versus input graph and our values. Here's a frequency of 3. So as you can see, in this graph right here, we had a more varying data. It starts to, just become a linear line. But you can still represent the peaks here. There's still our peaks. So, and graphically obtained, this is from the lower range of Trent's results, and here's in black is the my upper range, 3.5 to 4. And the results really don't vary too much. We still have a little bit of varying, but we found that in the lower range and the upper range there wasn't too much of the difference, because we think it was due to the lights having to be turned on, like they're fully turned on more so at my range, and they're beginning to in Trent's range, but in the middle range it's kind of like the lights are just getting there, so you always have varying results. Here's our mode plot, which is our frequency versus, well, here's the frequency versus our degrees, and frequency, frequency versus order, this, we searched for at 180 degrees, because this is where you find the FU value. We go up and cross into our amplitude ratio. That's right, amplitude ratio versus frequency, to find what our 1 over KCU value is. And we find what our FU is, which came out to be 7 here, which is fairly high. And our order was the slope of this line. And our K value is represented right here of our amplitude ratio. Here's how we found some other values using our equations. Once we had our K gain and our tau and our omega, we had our amplitude ratio and we solved for our omega. And then we plugged it in here to find out what our tau was, or our dead time. And here's some calculated values using those equations and using our Bode diagrams. We had 7 as our ultimate frequency again, and gain is 0.055. Our slope is about negative 1.5. 1 over KCU value, 0.025. And our dead time was still pretty high. It was very high in my range because of how the graph, I guess how it starts off. It just is off until later on in the graph. And here's our modeling of our bow diagram. We had our fit fell pretty good at the very end of our range. However, because the model fit is more smooth curved, we had a FU value of 5, which is from 180 and up. This is over 5. As you can see over there, I think it's over there. That's not how. I think it's on the next one. But our modeling fell, pretty well in our range. Here, this is our conclusion to our frequency response. This was the modeling one where you can see our frequency, our FU ultimate frequency was a little bit different, but really not bad. And mainly, like I said, because it wasn't a straight line down to our results. Our order was a little bit different, but the rest of the values stayed pretty consistent. And that's it.